So next we have Dr. Professor Sabong, who is the Professor Emeritus of Ophthalmology, Faculty of Medicine, Sri Raj Hospital. Thank you, Dr. Sabong, who's going to talk about the impact of total keratometry from the iMaster 700 in IOL calculations.
Great, thank you very much, Dr. Yo, and thank you, Zeiss, for the invitation. It's always been good to be among friends and colleagues to share some of the ideas how do we do the calculation and the surgery now. So my talk is going to be about the impact of the total keratometry for the IOL calculations. And I believe that many of you are already aware of the total keratometries. And if you look in the printout of the Zeiss iMaster 700, so it gives you two sets of the keratometry. The first set is what we call the standard keratometry, or in other words, we could call it the keratometric index keratometry. And the second set is what we call the total keratometry. And by looking at these two values, it's actually helping me a lot in the way I am doing the calculation in the patient's eyes. And first, we have to come and see what is the difference between these two values, because the algorithms to derive these two values is different. So the difference is this. So you may be aware that for the standard keratometry, we're usually measuring just the front surface of the cornea by using the telecentric camera from the Zeiss iMaster 700. And this will modeling the front surface of the cornea only. And then it uses the keratometric index. Most of the time, we use 1.3375 to estimate for the posterior cornea. And then you end up with this standard keratometry. But for the total keratometry, it's different. So by using the front surface, and then they're trying to measuring the posterior cornea as well by measuring the thickness of the cornea using the swept source OCT. And once you have the front surface and you stack the data of the cornea thickness on top of the front surface, you will modeling the posterior cornea. And this time, you have the data of the front and the back surface of the cornea. Now, you don't need any more of the keratometric index. You can use the real data of the front and the back without any estimation of the posterior cornea, and you end up with this value, which is most of the time we call it the true cornea power. And actually, this measurement has been done before in another corneal topographies, and we find that when you use the value of the true posterior cornea, it ends up with a different value of the keratometric index keratometry. So we had the study back in 2019 to see what if we're going to use the real posterior cornea data, what would it be equivalent to the keratometric index that being used. So it turned out to be, it should be 1.3315 instead of 1.3375. So therefore, these two values, if you need a real data to put it in, it would be different. So it's end up with the difference in the IOL power calculation. So when Zeiss derived this posterior cornea data, so they're trying to stay compatible with the previous K that we have been using. So what they do is actually they're trying to calibrate this back to match with the keratometric index. So by doing that when they do the calibration back, you would see that these two values should be very close because it's calibrated back to the keratometric index. Only in the case that the front and the back surface relationship would be in the normal range. But in any case that you see these two values is different, so that means the front and the back of the cornea in that particular eye is not in the normal range, something might be wrong with that eye. So it would be very good if you take a look at these two values and compare these two values together. Now you might ask that when you calibrate it back to the keratometric index, what would be the benefit is that then? Because these two values is very close anyway, so why do we have to go for the total keratometry? Why don't we just use the simple keratometry? So the answer is this. I give you an example. So if you have two eyes that have a very same front surface, and if you are going to use the keratometric index for the calculation, it will estimate the posterior cornea the same way because this is using the same keratometric index. So you end up with these two eyes, the same standard keratometry. But in fact, even though the front surface is the same, but the back surface of these two eyes might be different. Now, if you're actually measuring the posterior cornea, and then even you calibrate it back, but the starting point of the posterior cornea in these two eyes would be different. So it still, it still carry some information of the posterior cornea, even though you calibrate it back. And it will show you that Once you calibrate it back, in this case, that if the AP relationship is not in the normal range, it will show the difference between the K and the TK. And I think this is very benefit to me because when I look at the patient's measurements, I always compare these two values together. So we have the study in 2019 looking in the way of using this total keratometry. And if you look at, this is in the normal eyes, of course, in the normal AP relationship, you will see that the K, the standard K, and the total keratometry is very close. So this study is showing you 44.56 and 44.59. And because of this, Zeiss has done a very good job in trying to stay compatible. So in other words, it means that you probably don't need to do any optimization if you going in the normal eyes range, if you want to change from the standard keratometry to the total keratometry. So we look back into the data and we see that if you are going to use the different K, what would be the optimized constant? You will see that across all the formula, the constant optimization between these two values is actually very close. The difference is actually quite negligible. So whatever you're doing good with your standard K, if you want to shift to use the TK, you probably can do it right away without any optimization. You can use the standard formula that you are using now, use the same constant without any change, and the result would be very good. And in that paper, we actually show you the result of the refractive outcome across all the formula using the standard K comparing with the total keratometry. It is showing that in the total keratometry, actually giving you a little bit better in terms of its lower mean absolute errors and lower median absolute errors. And especially if you look at the Barrett TK formula, which is specifically designed to use with the TK formula, it gives you the lowest mean absolute error and the lowest median absolute error in this study. So you know, these two values is very close, but it not exactly be the same. So how much different would it be? So this is the agreement plot to show you the difference in this group of the study patients. And you see that most of the cases, the difference between these two values should be less than 0.1. But if you look at two standard deviations, so it's running between 0.2. So for me, when I'm looking at these two values together, so if the cornea is in the normal aspect between front and the back surface, these two values should be different less than 0.2. In any time that you see these two values is different more than this number, you have to thinking about now. That means the front and the back relationship is not in the normal range, so the way of the calculation might be different. So you probably cannot use the routine method of the calculation, and you might end up with some refractive surprise. So it just gives you something that you have to be careful. I'm giving you the example. So this is the case that you see that the standard keratometry giving you 45.6, but for the total keratometry, it's giving you 46.01. So this is about 0.2 different. It's actually higher than the acceptable range for me, for myself. So that means that in this particular case, there is something wrong with the front and the back surface of the cornea. The relationship is not falling into the normal range. So the estimation of the standard keratometric index might not be valid. And when you see something like this, the first thing you have to do is corneal topography is a must. Because you need to see the front and the back surface of the cornea, and you have to find the topography that giving you the information of the front and the back of the cornea, of course. But if you don't have one, so Zeiss is actually kind enough to provide you the front surface, at least for the central topography. And this is the central topography of that particular case. The central zone is probably about 4.0 mm. It depends on the curve of the cornea, of course. But in this case, you will see that this patient has a bow tie, but the inferior half of the bow tie is just look a little bit skew. So we go back and do the full topography, and we interview the patients again. It turns out to be that this patient, he put on the contact lens, and he doesn't take the contact lens out long enough. And so we wait for another 4 weeks and bring the patients back again. Now you see, this is exactly the same eyes. The topography looks pretty bow tie, regular bow tie to me. And now we repeat the measurements again. Now you will see that the difference between the K and the TK now is very close, so it's about 0.1. And when you see the difference like this, so it means I think you're safe for the calculation. You're ready to go for the surgery. But if you hurry and you do at the first visit, you will end up with something wrong with it. So this is just telling you that when you see the difference, you have to be careful. Is it real? Would it change? Would it be something that not permanent? So you have to wait and see sometimes. But in some cases that we see, and we use this for the benefit, is that when you look at the patients that have some corneal refractive surgery, and if you look at the myopic ablation, you always see that the K value, the standard K, is always higher comparing to the total keratometry. And it's the other way around. If you look at the hyperopic laser ablation, the standard K is always lower than the total keratometry. And the magnitude of higher or the lower is more prominent in the myopic treatment. For example, that -3 and +3, -3 has more change in the difference in these two values comparing to the plus treatment. And what else? What else? It's just like any kind of corneal pathology that you might think that the front and the back surface relationship is not on the average group. For example, like the corneal scar, like post-pterygium excisions that you do some corneal excisions or corneal transplant. Some case like this that you might imagine that the front and the back surface relationship might not be the same. You would see that these two values would be different. So I'm showing you, this is a study. This is a group I'm showing you. This is for the post-myopic LASIK. If you look at the difference between the standard keratometry and the total keratometry, you see that the total keratometry giving you a lower numbers comparing to the standard keratometry. And the other way around for the hyperopic treatment, the total keratometry giving you a little bit higher. And this is the group of the patients who had the corneal transplant and the corneal scar. You see that the K and the TK is showing you a very much difference in these two values. Now, it would be better if you go and using the TK, but you can't do it right away because you have to make sure that this change remain the same. Like the earlier case I showed you for the example that is a contact lens warpage that you probably have to wait a little bit longer. I'm giving you this case example that I'm using this different for my calculation. So this is a case come to see in the clinic that you would see that this is the phakic IOL has been implanted into these eyes. When you look at the slit lamp, I'm not sure you can see that. That is the LASIK flap in the cornea. And then you never know that what kind of ablation would be, has been done in this cornea. If you look at the biometry, it is very obvious that the patient has a very high myopia, very long axial length, and that's probably be the reason why the patients need to put in the ICL in at the first place. But it could be the overcorrections and the doctor is doing some hyperopic treatment. It could be the undercorrections and the doctor doing the myopic treatment, or it could be just the toric, because there was a time when the ICL won't provide you the toric version. You have to implant the spherical version in, and you cut the flap and you do just the toric ablation. And you don't know. So if you don't know, and if you look at the standard keratometry only, and 44/7, it's very, you don't know, because if you do a little touch up, the treatment might be very small, right? So we look at the topography of this case, so it doesn't really help much. This obvious very thin cornea, it could be the reason that why we can't do the laser treatment at the cornea at the first place, and we have to put in the phakic IOL. So you had an option. If you don't have the data of the relationship between the front and the back, if you only look at the standard K, you had an option that if you're going to go for the formula that you have to choose between the myopic corrections or hyperopic corrections. And if you don't know, the difference between these two calculations would be very high. This is about 1.5 with the Barrett through K. And it would be the same if you use the Higgins-L formula. You need to specify which type of the treatment that has been done into this cornea. And the difference between these two is even larger. This is about 2 deltas difference. So if you have the front and the back relationship, and if you look at the TK, now you see that the TK is giving you a higher value. And even though it doesn't beyond 0.2, it's just giving me the trend that if I want to bet, I would bet this eye going for the hyperopic treatment because of the relationship of this front and the back surface. So if you go for the hyperopic treatment from the Higgins-L and for the hyperopic treatment with the Barrett through K, so it gives you a very close +11. But one formula I always use for the confirmation is that you can use the TK on the regular Higgins. And in regular high gaze, there is no need to specify the myopic or hyperopic treatment because this is a regular high gaze, and you put in the TK into that, and this high gaze TK giving you 11.5 plus 11.5. So I'm pretty confident that this eye probably have been done a little touch up on the hyperopic treatment. So we implant plus 11.5 in this eye, and it turned out to be perfectly right. So this is another case that the patients come in and have a cataract, and the patient don't even remember what has been done into the eye. We look at the slit lamp, we see the flap. And you look at the biometry, it doesn't really help much because it just looks pretty average to me in the axial length, in the K readings, and topography doesn't look very helpful to differentiate between these two things at all, between hyperopic or myopic ablation. And once again, and if you look at the front and you look at the back surface, it's just giving you the idea of the trend of what kind of treatment should be performed in these particular eyes. So to end my conclusion about the talk is that, to me, every time when I look at the printout, I always compare these two values. And if these two values is very close, most of the time it's less than 0.1. If it's very close, the front and the back relationship is good, so you're probably fine to go for the calculation. If these two values is different, the first thing you must do is you must do the corneal topography. And then sometimes you might have to wait a little longer, and you have to bring the patients back and repeat the measurements again to make sure that this relationship remains valid. So that's, thank you very much for your attention.
Thank you, Dr. Sabong.
Yes.
I think that was an excellent. I think if you want to take any key takeaways, is really looking at standard K and TK values in determining whether this patient had a hyperopic LASIK or myopic LASIK. Really, really helpful in my practice. Yeah. Thanks, Dr. Sabong.
Yes, thank you.